Okay, guys. So here's an example of what I'll make you guys do on the test. So I'm going to give you a polynomial that's all factored out like this. So what I mean by factored out is it's all split up. So a factor, this binomial x minus 2 is a factor, and this binomial x plus 5 is a factor. Okay, so what we could do is we could go ahead and distribute this, and we would end up with this polynomial. Okay. Where we do these quadratics and we get x squared plus 3x minus 10, and then we distribute the x. So the whole point of me showing you this is all that really matters, remember, is this lead term. So once I find out what this lead term is, then I'm fine. So what I could do is I could just do this all at once. Well, I know the x is going to multiply this x, and it's going to multiply this x, and it's going to be 1 times 1 times 1. So that's why I get this lead term of 1x cubed, okay? So something that's really helpful here is if we take and we find the zeros, okay? So what we're going to do is we're going to say, hey, I need to find all this function's zeros. So I'm going to take this first one. I'm going to look at this x, and I'm going to say, well, I can put 0 in for that x, and I get a 0 that's right here. And let me pick a better color. And it's right here, okay? So you get that 0 right there. So there's a 0 at 0. Then over here, we get a 0 at negative 2. So again, remember, what makes this equal 0? So you could always set it equal to 0. X minus 2 equals 0, and then solve for x to get to x equals 2, or you could look at the opposite. So we're going to have a 0 at 2. Mark there. Okay, and then we're going to have a 0 at negative 5. So over here. So let's just put some numbers there. So we got a 0 over here at the number 0. So we got a 0 at 0. We've got a 0 over here at 2. And then finally a 0 over here at negative 5. Okay, so first thing is we want to know where these zeros are because they're the x-intercepts. So they're going to help us determine how this is going to look. Okay, so then, and then bear with me with this not so, with, me doing paint. Okay, so what I'm going to do here is I'm going to lean on my parent function. So my parent function has an end behavior. Ugh, that's no good. Has an end behavior of this arrow up here, right? So I know that this function wants to do this over on the right side, and over on the left side, it wants to go down. Now this is because, remember, this is because what we have here is the parent function, because there's no negative in front, okay? So now I know that this parent function has to intersect at these zeros. So what it does is it's going to take this 0, and it's going to say, so it's got to start at this end. So it's got to start at this, okay? This is got to go through negative 5. So see how it's going to go through negative 5, and then it's going to hit a max. And then it's going to go through 0, and then it's going to hit a min, and then it's going to shoot through 2. So something like this, okay? So we're going to get that, and then we're going to see that this, this arrow has to be right here, and then this arrow is the down arrow, right? So again, we're just leaning on the cubic function, and we're saying that, hey, if I have these zeros and these end behaviors, this is the picture of my function, right? And then so from there, we're just doing domain and range, and the domain is everything because I can put anything in for these x's. So I'm going to say x is on the infinite domain. So imagine that's infinity from that, right? And then from there, you're going to get the range. Well, the cool thing about this is the range is the same way, right? It goes from negative infinity to infinity as well. So now what we really got to do is the end behavior, right?